All right, when we're looking at integrals, they often love to ask, they give you a rate and they're asking then for an amount, okay, how much. So if you integrate a derivative, don't forget, if you integrate a derivative, they cancel out and I'm left with the position or the quantity or the amount. So in this case, when I integrate my rate, when I integrate my L of t from, and it says, we're talking about hours, and it says how much oil is leaked out for the first half hour. Because our units are hours, I'm going to say 0 to a half, okay, because we're dealing with a half hour. I'm going to go ahead and type in math 9, type in my L of t function there, and that's going to be 0 to 1/2 of 1 plus the sine of t squared. And when you type that in radians, don't forget, we get 0.541. All right, here they gave us the velocity again. They want to know my position. So when you integrate velocity, you'll get position. But notice what they said. They said the particle is at 4 when t equals 0. So be mindful, the starting position, I'm not starting, say, at the origin. I'm starting at position 4. So I'm going to go ahead and say 4 plus, and then I'm going to say my bounds are going to be 0 to pi over 2. So let's think about this. If t was 0, or if my upper bound was 0, an integral from 0 to 0 is 0, and so at time t equals 0, I'd have my initial starting point of 4. So now I've got to take the antiderivative of sine of 2t from 0 to pi over 2. That'll get me my distance traveled over this time period. Then I will adjust from where I started and add 4 to my final answer. Okay, let's see if we can take an antiderivative sine of 2t without using u sub. You could use u sub and have your u be 2t, but let's think about that. The antiderivative of sine is whose derivative is sine? It's negative cosine. And do you agree that this derivative is supposed to get me what I started with? Well, the derivative of negative cosine will be positive sine of my angle, but then I'd have to multiply by another 2, and I don't need that. So I'm going to do the opposite of multiplying by 2 and dividing by 2 to counteract that extra chain rule 2 that I'd get. I need to evaluate this from 0 to pi over 2. Again, my 4 is going to hang out front. I'm even going to just leave my minus sign, and I will distribute. You know what? I'm going to be crazy. I'm going to leave the 1/2 as well. And I can distribute that later. I'd have the cosine of 2 times pi over 2 and minus the cosine of 2 times 0. That would get me 4 minus 1/2 times the cosine at pi is -1. The cosine at 0 is 1. Again, I'd have 4 minus -1 minus 1 is -2. And 4 minus, and then I'm going to multiply my -1/2 times my -2 to get me a +1. So 4 plus 1 is 5. Woo! Let's think back. What happens when we need to take the derivative of an integral? They cancel each other out. We're going to go ahead and plug in my upper bound. We've got 1 over 1 plus my upper bound squared times the derivative of my upper bound. The derivative of x to the 1/2 would be 1/2 x to the -1/2. Minus plugging in my lower bound would be 1 over 1 plus 1 squared times the derivative of my lower bound. The derivative of 1 is 0. Therefore, this quantity does not matter. When I go to simplify my answer, I've got 1 plus x on the bottom times a 1 over 2 root x on the bottom. Multiply those two together, and we've got a. All right, here they gave us the antiderivative. They said if sine of that quantity is the antiderivative for f, so if I were to say I need the antiderivative for f and we get the sine of 1 over x squared plus 1, if we've got the antiderivative that they gave us, okay, I just needed my pen. Boop. Oh my gosh, pen. Okay, then they said then the integral from 1 to 2 would just be that antiderivative from 1 to 2. So I'm going to go ahead and plug in 2 to my antiderivative minus plugging in 1 to my antiderivative. That would be the sine of 1 over 2 squared plus 1 would be 5, minus the sine of 1 over 1 squared plus 1 would be 2. You can use your calculator and you will get negative 0.281. Answer A. All right, at time t equals 0, a forest preserve has that population of 1,500 deer. If the rate is R of t, the rate of their growth is R, which is a derivative, what is the population at time t equals 3? So if I integrate my rate, I'm going to get the amount. And again, when t equals 3, so I'm going to say from 0 to 3. But that's going to get my amount starting at 0. Don't forget, we already had 1,500 deer in the preservation. So go ahead and add 1,500 to the integral from 0 to 3 of R of t. Type that into your calculation, into your calculator, and you'll get 10,141 deer. Option D. All right, here we're looking at h versus h prime versus h double prime, and all we know is h is the integral. So if we're looking for h of 2 would be the integral from 0 to 2 of f. And they gave us a graph of f. And correct me if I'm wrong, the integral from 0 to 2 would be a positive value. And they want us to order my h prime, and h double prime in order from, looks like least to greatest. So h of 2 is a positive value. Let's go find h prime of x. H prime of x would be the derivative. H of x is here, so the derivative of the left. I'm going to have to take the derivative of the right. The derivative of an integral cancels each other out, and I'm left with the function with respect to that upper bound. So if they want h prime of 2, that's going to be the same as f of 2. F of 2 per my graph is 0. Okay, so my first answer was positive. My second answer was 0. Let's go see what h double prime of x is. Well, if h prime of x is f, then h double prime would be f prime of x. H double prime of 2 would be f prime at 2, and what that means is what is the slope when x is 2? When x is 2, the slope of that tangent line would be a negative value. So the smallest value would be h double prime. The next biggest value will be h prime, and my largest value is h of 2. I like answer E. Okay, we did this problem recently in class. If it says, again, sand is being added to a beach at this rate, S is the rate of tons per hour that the sand is being added since 5 a.m., how many tons of sand are added over the 3-hour period from 7 a.m. to 10 a.m.? So again, if you integrate your rate, you're going to get your amount. If at 5 a.m., that's really kind of my initial time where t is 0. So 7 a.m. is 2 hours after that. 10 a.m. is 5 hours after 5 a.m. So my bounds will be 2 to 5. When you type that in using Math 9, you'll get 255.358. All right, the temperature in a room at midnight is 20 degrees Celsius. Over the next 24 hours, the temperature changes at the rate modeled by H. Here's our H, and that's a rate. In degrees Celsius per hour. All right, which of the following is the best interpretation of the integral from 0 to 6? And again, those t is measured since midnight. So if we just want to interpret it, since h is measured in degrees Celsius per hour, when you integrate degrees Celsius per hour, we're going to be left with the amount of degrees, okay? It's going to be the amount of degrees that the temperature is changing from when to when. Well, if midnight is when we're starting, midnight to 6 a.m., so I'd go ahead and say that we're dealing with the change in the temperature in degrees Celsius between midnight and 6 a.m. I like C. I do not like B because it says average temperature. We'd have to divide by the amount of time. A is saying the actual temperature at 6 a.m. No, we're adding up all the temperatures. We are finding that change in the temperature, not just finding an actual temperature at 6 a.m. And then D is talking about the rate. Well, we're integrating a rate, so we're getting an amount. We're getting the actual temperature. All right, 84 is going to be that fundamental theorem of calculus. So in 84, don't forget, if you integrate an f prime, we're left with a function. And if I integrated an f prime from, say, a to b, we'd be left with a function from f of b, minus f of a. So in this case, my f prime is root x cubed plus 6. We're going to integrate that from this x to this x, 1 to 5. And that would equal f of 5 minus f of 1. Now, you can go ahead and type this side in your calculator. And when you do, you will get 24.672. F of 5, we don't know what that is, but f of 1 is pi per the information they gave us above. I'm going to then add pi to the left-hand side, and when I add pi to 24.672, I'm going to get 27.814. All right, so this is another fundamental theorem of calculus problemo. If f is the antiderivative of this function, x squared over 1 plus x to the 5th, and the antiderivative is f, okay, then they gave us some x values, 1 and 4. I'm going to make those my bounds. So the antiderivative would be f of 4 minus f of 1. Y'all, you've got a calculator. You can go ahead and plug in this left-hand side. When I plugged in the left side into my calculator, I got 0.376 equals, again, f of 4 is what we're looking for. F of 1 is 0. So, okay, then I have my f of 4 is 0.376, and the answer is D. We're going to follow that same process with this next one. Let big F be the antiderivative of natural log of x cubed over x. And again, big F is the antiderivative. I'm going to go ahead and use these x values as my bounds so that I then know from 1 to 9, the antiderivative of that function would give me f of 9 minus f of 1. Go ahead and type in this left-hand side to your calculator. I got 827 equals f of 9 is what we're looking for. F of 1 in this case is 0 again. So again, we got f of 9 is 5.287. And that is going to be 5.827 rather. I love these for some reason. On number 39, what we've got is just remembering our integration rules. So if we've got the integral from 1 to 10 is 4, and from 10 to 3 is 7, we need to know if we were to flip those bounds and we'd make it from 3 to 10, we've got to negate our answer, which would be -7. So if they're asking for the area from 1 to 3, I could say, all right, well, I'm going to take my total area from 1 to 10 minus my area from 3 to 10, and I would be left with the area from 1 to 3. So I'm going to take my 4 minus my -7, and I would get 11 for my area from 1 to 3. Everyone, we have not done volume yet, so you can skip this question, part C. Let's go ahead and take a peek at 87. 87 says we are giving you h is an integral. Ooh, this is getting wonky. H is an integral. On which of the following is h increasing? Well, h will be increasing when this area is positive. And this is the area of the f graph. Again, this is the graph of f. And if I were to start finding the area from where this begins at -1, we've got negative areas, and then we've got positive areas above the x-axis. So my h will be increasing when my x's are from 3 to 9. Okay, how they asked B is pretty interesting. We can totally handle this. They want the antiderivative of this function, and notice how we've got an f prime in there. I'm not worried about it. We got this. So the integral of 3, or whose derivative gets me 3, I'd say 3x. Whose derivative gets me 5f prime? Well, whose derivative is f prime? I'd say f. And again, if we want to make sure that we did this right, the derivative of this needs to be that. The derivative of 3x is 3. My -5 is a constant, it gets to stay. The derivative of f is f prime. We're then going to analyze this from the bounds that they gave us, 2 to 13. I'm going to plug in my upper bound, 3 times 13, minus 5 times f of 13, minus 3 times 2, minus 5 times f of 2. All right, 3 times 13 is going to be 39, minus 5 times f of 13 f of 13 is going to be 6 minus 6 minus 5 times f of 2, which would be 1. We could end here, but I'm just going to get the final answer because I like this stuff. We got 39 minus 30, and then in the brackets I'd get 6 minus 5 is 1, so minus a 1. 39 minus 31 is going to get me 8. Okay, they gave us the velocity. In order to get the position, we're going to integrate velocity. So I'm going to integrate my 1 plus 2 sine of t squared over 2. And I'm going to integrate that from 0 to what? And it says at time equals 2, the particle, I'm sorry, was at 2 at time t equals 4. So if I set my integral with my upper bound being 4, I'm going to change this color because I think that this is a hard step. If my upper bound is 4, and I take this antiderivative of velocity, I should get my position, and I'd get my position at 4 minus my position at 0 to get my total distance traveled. Because again, this was the point when x was 4, when my time was 4, my position was 2. So I know S of 4, I know I can fill this quantity in. S of 4 is 2, and I could make a substitution with that. So I'm going to type in the left-hand side to my calculator, and when I do that, I get 5.815. S of 4 I know is 2. It wants to know what is my position when I begin at t equals 0. I'm going to move my S of 0 over, and that means I will have to subtract my 5.815 from 2, and I'd get negative 3.815. And that means I'm starting at negative 3.815. To get my total distance traveled from 0 to 3, that word total is so important because now they want to take the absolute value of my velocities to give me credit for everything. I'm going to take that integral from 0 to 3 because that's the interval that they wanted me to do. dt, I'm going to plug that into my calculator and I'll get 5.301. This one's got a lot of words for me only giving you part A. If we're asking for how many cubic feet of rainwater flow in, and again, the water is flowing into the pipe with the R of t expression. If we're looking at that quantity from 0 to 8, I'm going to integrate from 0 to 8 that R of t function with math 9. I'm going to plug that into my calculator and get 76.570 cubic feet of water.